Okay, in this video we're talking about graphing different trig functions with different amplitude, phase shift, and periods. So this first question here is going to ask us to state the amplitude of the function y equals -2 sine x and graph. Well, we know the amplitude is what the number that comes right before the trig function, that is -2, but we know amplitude is always positive. The amplitude is 2. All right. However, don't disregard this negative sign here, because in that when we were learning about the graphs, if I told you to graph the parent graph x squared, it was a parabola like this, right? But if we change the number out in front of it to like a -3x squared, all right, the 3 makes it get skinnier, and the negative reflects it over the x-axis like this. All right, so that negative does mean something when they tell you to state the amplitude. The amplitude is always positive. Okay, so the amplitude's 2, and what the amplitude means is how far up and down that graph is going to go. And notice for amplitude only occurs in a sine and a cosine graph. And the reason for that is because sine and cosine graph normally, in a normal graph, let's show you what a normal graph looks like, and we'll graph a regular graph. A normal graph is, okay, it's going to oscillate, which means it's going to go up and down between 1 and -1. Um, so here's a normal graph. The sine function, sine is 0 is 0. If I go 90 degrees, and then we go 180 degrees, and then we go 270 degrees, and we go 360 degrees. Those are when my main points are going to occur. The sine of 90 is 1, so we plot 91. The sine of 180 is 0, so I plot 180, 0. 270 is -1, and the sine of 360 is 0 again. That is the regular graph right there, and it oscillates between 0 or between 1 and -1. So it goes like that, and obviously it continues on and so forth for as long as you can go. All right, so what we're doing now is we're taking now the sine of like 0 degrees, and now we're multiplying it by -2. Well, that's all right. The sine of 0 degrees is 0. So when we multiply that -2, it doesn't do anything for us. Let's make this graph in red. All right. Now, however, the sine of 90 was 1, but we're going to multiply it by -2. So that's actually going to go down to -2. And since we went down to -2, we're probably going to go up to +2. All right. And then the sine of 180 is 0. So -2 times 0 is still going to be 0, right? All right. The sine of 270 is -1. And that times -2 is a +2. So 270 is going to come up here. And then obviously the sine of 360 is 0 times -2 is still 0. And so I'm going to graph this right here. So notice that by putting that 2 in front of it, it made it go much higher. All right. And then with that negative sign above it, also reflected it over the x-axis. All right. Okay. And these go on forever in the negative direction and in the positive direction. Okay. So that's what graphing something with a different amplitude looks like. Now we're going to state the period and phase shifter for the function y equals sine of 2x plus 180, and then we're going to graph it. Okay, so now we're changing two things. We're changing the period, and we're changing it. We have a phase shift because we have a plus something inside this parentheses. We could also change if maybe this gave us a 4 out in front. It also changed the amplitude. It would go up 4 units up, 4 units down as well. All right, well, let's talk about this. All right, the period is for a sine function. The normal period of a sine function is 360 degrees. We just saw that up above. It repeats itself every 360 degrees. To find period, we go 360 divided by k, and k in this case is 2. Okay, so what we're going to have now is we're going to have a period of 180 degrees, which means our graph is going to repeat every 180 degrees. All right, and then we also are asked to find the phase shift, and phase shift is -c. This is our c value, so -c, so -180 divided by k, and k is the number that comes before the angle of the x, or sometimes it's x, sometimes it's theta. All right, so -c all over k. So we have a phase shift of -90 degrees. All right, so what that means our sine function is going to start to the left 90 degrees. And it's going to have a a period that occurs more often than a regular. Again, let's graph the regular sine function. Again, this will go quick because we've done it so many times now in the last couple of videos. This is 90, this is 180, and this is 270, and this is 360. All right, I'm not going to go into big depth because we've graphed this so many times in our videos. So that's 1, 0, -1, and 0. That's what the regular, and then let's do this. Let's go -90 this direction and here. All right, so the regular sine function would look something like this. Okay, and so forth. So now let's graph something that let's graph a sine function. Now the period is going to happen 180. So what it's doing, a period is of a normal sine graph is from 0 to 360. It's got to make this curve right here. It's got to go up to 1, down to -1, and then back to 0. That's one period right there. Okay, so now it's got to do it in half the time, but we also have to shift it to the left 90 degrees, which meaning we got to shift our points to the left 90 degrees, all right, because we have a phase shift in here because of this guy right here. All right, so everything's going to be shifted to the left 90 degrees. Now we have a period of 180. So from -90 to 90, that is 180 degrees. That's got to be our endpoints, right? Just like how here is an endpoint for our regular ones from 0 to 360, all right? So in between here, it's got to go up to 1, through 0, and then back to down to -1, and then back to 0 there. So what we do, our period, if you notice in the regular guy right here, is broken into fourths. There's 1 tick, there's 2 ticks, there's 3 ticks, there's 4 ticks, all right? And if you think about it again, all these are occurring on the axes of our unit circle when it hits the axis of the unit circle. So we're looking at ordered pairs when it hits 0, when it hits 90, when it hits 180, and when it hits 270. And notice this is broken into 4. So when we're talking about in the period, we're going to have 4 critical points, all right? So we're going to have, the starting point, and then we're going to have 1, 2, 3 in the middle, and then the ending point, all right? So what we're going to do is we're just going to take 180 and divide it by 4, and that'll give us our points where our critical things happen. So where 1 happens, and where 0 happens, and when -1 happens, and so forth. So we're going to go ahead and take 180 divided by 4, because it should be broken into 4s. So 180 divided by 4, or we're left with 45 degrees. So every 45 degrees, this is going to do something pretty important. So let's go ahead and mark these on the graph then. This has got to be -45. This is 0, and this would be +45. Okay, and that's true for anything. If you have a period of 90, divide that by 4, and that gives you where you should mark your marks here to graph, your important things to graph. So a color that I haven't used yet, I don't really have one, I guess. Let's just make this graph in black there. Oh, let's make it in red. Okay, so our important part was 90 degrees, so we're starting at, or -90. That's our starting point. It said something important happens every -45 degrees, so it's not reflected over the x-axis or anything, so it's going to go up to 1 at -45, back to 0 at 0, and then it's going to go down to -1 at 45 degrees, and then it's going to be back at 90, and so forth. And this would actually, if I kept going, would continue this pattern. I guess this would be, what, 135? And then 180 would be my next 45, and then this would be, what, 225, and then 270 plus 45, what, 315. Okay, so it's going to keep doing this pattern, and it's going to be going twice as fast as the original graph. All right, so that's what our new graph is doing. Again, look at it, it's making more revolutions. It's happening twice as fast. They ended at different. It ended up different here. Notice that every important part is shifted 90 degrees. If you look at, well, I guess not really because the period is different. But if you look at this thing, it's starting to the left 90 degrees and it's going twice as fast. So that's the point I wanted to get across to you guys today. I hope this helps. We'll see you in class.